The first question: a block of mass m1 is resting on a horizontal table. A light string passes over frictionless pulley, and there's another block B. This block A, this mass m2 suspended. The coefficient of kinetic friction. So there is a frictional force which is here. The coefficient of kinetic friction mu k is given to be mu k. The block A is sliding towards the right. Obviously this will also slide down, and so you can take the free body diagram in here, and there will be a tension T and T. So then the T minus frictional force is equal to m1 into A. T minus the frictional force itself is m1g mu into normal reaction. So then mu into m1g is equal to m1 into A. So T therefore is m1A plus mu into m1g. Taking the free body diagram in this, you have an m2g which is acting downward and a tension upward. So m2g minus tension is equal to m2 into A. Therefore tension is equal to m2 into g minus m2 into A. Equating both these tensions, you get m1A plus mu into m1g is equal to m2 into g minus m2 into A. Consolidating A, you get m1 plus m2 is equal to m2g minus mu into m1g. So then what is common in here is g is common. Okay, so then g common, m2 minus mu into m1 by m1 plus m2 gives you the acceleration. Okay, and that you have to find the tension, so you have to substitute in one of the equation. T is equal to m2g minus m2 into A, where there is a g into m2 minus mu m1 by m1 plus m2. And can you see that an m2g is common in any way? M2g is common, 1 minus m2 minus mu m1 by m1 plus m2. So when you take LCM, m2g, so you have an m1 plus m2 minus m2 which is getting cancelled, plus mu into m1 by m1 plus m2. And so then from here, if you see, m1 also can be taken out common, m2 m1 m2 into g to 1 plus mu k, this is mu k, by 1 m1 plus m2, and that gives you the tensions at final formula. You can memorize this formula and you can substitute in the questions. If similar questions have been given, you don't have to really resolve. You can just multiply m1 m2 into g into 1 plus mu k by m1 plus m2. So let's go to next question. So this is the next question. There is a block and trolley system. Okay, what is the question here? That's a diagram. That, one second, hold on. So now it's getting recorded. Can you see this is the question, the second question in this PDF? You have a trolley for mass 20 kg, and which passes over frictionless pulley here, and there is another block here whose mass has not been given, in the sense it's not seen, it's cut off, it's 3 kg. Okay, and here also you have a coefficient of kinetic friction, a frictional force like this and a tension like this, and they've already given that the mu k is equal to 0.04, and if the entire system is going to accelerate, what is the tension in this thing, what is the acceleration? Okay, so for me, I remember this is 30 Newton which is acting downward, that's 200 Newton, and there is the normal reaction. I remember the final formula for tension which we just found out. It was m1 m2 into g into 1 plus mu k by m1 plus m2, so that I can directly find the tension. It's m1 into m2 60 into gravity is makes it 600, 1 plus 0.04 by m1 plus m2 is simply m1 plus m2 is only 23. So it's 600 into 1.04 by 23. Okay, 104 into 6 is 6 4 is 24, 6 0 is 0, 6 1 is 6. So double 0, so makes it 624 by 23, which will be 27 point something approximately Newton. And the options are not visible here, only the solutions have been given. So I am sure just by substituting, but they ask for acceleration. When they ask for acceleration, even more easy. Once you can only remember tension's formula, and you know acceleration will be 30 Newton minus t, taking the free body diagram in here, which is 30 minus t, which itself is 27 approximately, is equal to mass, that mass into A, which is 3 into A. So substituting approximately 27 here, So you get a 3 is equal to 3a and a is equal to 1 meter per second square. This is only approximate, you still have decimal values, but I can't see the options in here. Okay, so then they've given the actual answer for it, it's 27.1 Newton here. And then the acceleration part, the acceleration is 22 by 23. The acceleration is actually 22 by 23. Okay, so that's what it is, because I've just approximated, and so then you can find the closest answer if the options have been given. I'll tell you what the options were. No, I can't see the option again. So let's go to next question. So A is equal to 22 by 23 to be more precise. So if you continue to divide it properly, you'll get 27.1. So 27.1 means it's 30 minus 27.1, which is 2.9 is equal to A. 30.0, 27.1. So it will be 9, this will be 9, so 2. So hence it's 2.9 by 3, or A is equal to 2.9 by 3, or 29 by 30. So then therefore it is 0.29 divided by 30 is 9s are correct. 30 9s are 9 3s are 27. 270. 20, and then add another 0, and 6 3s are 18. 180. 0.6. No, it's 0.9. 9 3s are 27. 0.9, 270, and then there's 180, so it's 6. 0.96 approximately, and that will be meter per second square. That's the actual value if you don't round it off. Okay, let's go to next question. The third question. The third question, a plank with the box on it at one end is gradually raised about the other end. So you're raising the plank. You're raising this plank. The normal reaction will always be like this, and mg will be down, that you know. And there's a theta which has been given. As the angle of inclination with the horizontal reaches 30 degree, when theta reaches 30 degree, the box starts to slip. That's what is called angle of repose, right? But the plank with the box on it at one end is gradually raised. Okay, basically the inclined plane is like this with a plank on this. So this end is getting lifted up. So as it gets lifted, when the angle gets to 30 degree, the block starts sliding down. That is the understanding, okay? So I hope you understood the question. The box starts to slip and slide 4 meters down the plank in 4 seconds. So it's going to slide down by 4 meters in 4 seconds. The coefficient of static friction, kinetic friction between the box and the plank will be respectively, it's not been given again. So we are supposed to find the coefficient of kinetic friction and the coefficient of static friction and the kinetic friction based on this information, okay? So given that the plank with the box on it at one end is gradually raised at exactly 30 degrees, the block starts to slip and slides down by 4 meters in 4 seconds. Okay, that's the given information. And you know that nu s, tan 30 is when it's just about to slip. So then it's just about to slip, or then it's mu s maximum limiting friction itself is tan 30. And tan 30 is nothing but, what is tan 30 is 1 by root 3 is tan 30. And 1 by root 3 is nothing but 1 by 1.732, which will get you to an answer of 0.6. Okay, that gives you the mu s, which is what they want. So the next is they've also given that they would like you to find mu k, but to find mu k you need to know what is the acceleration and stuff. So then you know that it's falling through a distance of 4 meters. So s is equal to ut plus half at square, and it's falling through a displacement s is and u is 0, because from initial, and half into at square, where you know that we have to find what will be the acceleration. Let's resolve this. This is mg, and so this will be theta, and this is mg cos theta, and this will be mg sin theta. And there is a friction, obviously the friction is on the other side. You know that mg sin theta minus frictional force will result in m into a. So when finding acceleration, you can resolve the forces. Mg sin theta minus frictional force is equal to mass into acceleration. the mass of the block is still just m, right? You can keep it as m, I think. Okay, so but the thing is mg into sine theta minus, we don't know the mass, it's okay, it's mu into normal reaction, where it's mu into normal reaction. So then mu into normal reaction as mu k into normal reaction itself is mg cos theta is equal to ma. So m throughout get cancelled, so you don't have an m, that's not a problem. So you g sine theta, which is g is 10 into sine theta is sine 30, and a sine 30 is 1 by 2 minus mu k, and you don't know what is mu k, and you know that there is a g which is again a 10 into cos theta, which is cos 30, and cos 30 is root 3 by 2 is equal to a. And you know, you have to find, but you know what is the how do you find the acceleration? You don't know the acceleration, you neither know the mu k. So this is the acceleration that you got, and let's substitute it in s is equal to ut plus half at square. 4 is equal to ut 0, half into acceleration, this will be 5 minus, this is also 5. So it's 5 minus mu k into 5 root 3 is acceleration into t square. T square is given as 16. So this is becoming 8. And so 4 is equal to 5 minus mu k into 5 can be taken out completely common, so you can bring it down. The 5 can be brought down, and it can be brought down as 40 with the 8. So 1 minus mu k into root 3 is what is left. This becomes 1 by 10. So then you want what is mu k. So mu k into root 3 is equal to 1 minus 1 by 10. Mu k is equal to into root 3 is equal to 9 by 10. So mu k is equal to 9 by 10 root 3, and I don't know what are the options in here. Once again, mu k into, okay, 9 by 10, can I call 9 by 10 as 0.9 by, can I write this as 1.732, and let's write 1.7 closer, so 9 by 17. So when dividing 9 by 17, and it becomes 17 5, so some 5 is 35, 5 is 85. So then therefore it's approximately 0.5. Approximately 0.5. So 0.51 is the accurate answer. So thus you can find your mu k. Okay, so then that completes this question. So let's go to the next question. Okay, the fourth question in here, a system consists of 3 identical masses. Okay, so there's a mass m1. m1 is here. There's a mass m2 and there's a mass m3. And there's a table here. A system consists of 3 identical masses m1, m2, m3 connected by means of string passing over the pulley. The masses m1 hangs freely and m2 and m3 are in the rough horizontal table with coefficient of friction has been given to be mu. The pulley is frictionless and of negligible mass. The downward acceleration of mass m1 is, okay, the downward acceleration, if this is going to accelerate by m1, obviously by an acceleration a, this is also going to go towards the left, right? Yeah, so then since there are 2 blocks, it's kind of we have to be careful with this m2 and m3. So you'll obviously have, it's going to accelerate on the right, there will be an f2 which is the friction here and f3 which is the friction here. There are 2 f2 and f3, and there is obviously a tension here and a tension here. Okay, so this is the way you draw, and then on resolving, this is going to accelerate on resolving this free body diagram on the right, this one m2 plus m3, you know that will be frictional force, and so it's m2 plus, okay, there's a tension T on the left, since the acceleration is going to be on the left, so T is greater, so T minus F2 plus F3 minus of addition of F2 plus F3 should be responsible for an acceleration of m2 plus m3 into A. And thus you get the first equation, okay. So that is your first equation. And you know what is F2 and F3? It's mu into normal reaction. So T minus F2 is mu into normal reaction, mu into m2g plus mu into m3g, where mu is just the same for both. Okay, so M1, M2, but are they M2 has, okay, M2G is equal to M2 plus M3 into A. So thus you can write what is T from here. T therefore is, you can take it to the other side and write your equation. Okay, where T is M2A plus M3A. The whole point is to equate and get the acceleration, right? Downward acceleration, yes. So M2A plus M3A plus mu2 into M2, no, this is mu into M2G plus mu into minus, both of them with a minus sign, so it will become a plus, mu into M3G. So that will be my tension. Okay, and you see an M2G is common here, 1 plus mu, and M3, M2G is not common, M2 only is common. If you take M2, okay, let's keep it like that. So let's go to the left hand side and see the vector resolving in here. You know that there is M1G which is acting downward. So M1G minus tension is equal to M1 into A. It will have the same acceleration. From this you can write M1G minus M1A is equal to T. So can we equate both of these tensions? So then therefore you know M1G minus M1A is equal to M2A plus M3A plus mu into M2G plus mu into M3G. Okay, so you want to consolidate acceleration can be underlined. Taking this to that side, you get A into M1 plus M2 plus M3. Here you have M1G, G is common for rest of the things, you can take G common out. M1 minus mu M2 minus mu M3. So acceleration is therefore G into M1 minus mu M2 minus mu M3 by M1 plus M2 plus M3 will be the acceleration. I am not sure what the answer is. Let's see. They seem to have taken all masses are the same. Have they been, has it been given? 3 identical masses. Shit. Therefore, you know that they are all M. So A is equal to G into M minus mu M by 3M. So M can throughout get cancelled. So you'll get A is equal to G into 1 minus 2 mu by 3. So that is the answer. Hope it's recording. Yes. So that is how you do the sum. I hope you understand. Okay. So the next is a block of mass 5 kg is resting on a rough inclined surface for which the coefficient of friction is 0.2. When a force of 40 Newton is applied in the horizontal direction. So block of mass 5 kg is resting on a rough horizontal surface 5 kg and a force of 40 Newton is applied to it, the horizontal direction. The acceleration block will be, okay, there is a coefficient of friction, frictional force in this direction. The coefficient of friction mu k is equal to 0.2, and you know that this is 50 Newton and there will be normal reaction, and frictional force itself is mu into normal reaction, 0.2 into 50, 5 2s are 10, so it's 10 Newton is the frictional force. Applied force is 40 Newton, which means the applied force is greater than the frictional force. So then definitely there will be acceleration, and the net force is equal to applied force minus frictional force, which is 40 Newton minus 10 Newton, which will be 30 Newton is the net force acting on it. It will result in 5 into A. So therefore A is equal to 30 by 5, so 6 meter per second square. It's such a simple sum. So let's go to 6th question. So a block, next is 6th question. A given block takes n times as much time to slide down a rough inclined surface. So there is a rough inclined surface and smooth inclined surface, and this is smooth. Okay, so smooth you have and this is a rough inclined surface, and you have a block here and here, but here in the rough surface obviously you will have a frictional force which is acting on this direction. And as usual you have mg, and this is theta, and this is mg cos theta, and there will be an mg sin theta to the left. Whereas in the smooth surface you will only have an mg and a mg cos theta, this theta, so mg cos theta and an mg sin theta. There's no frictional force because it's smooth. So this is a smooth surface, and this is a rough surface, and that's a frictional force. Okay, so now you have a frictional force in that direction. So sixth question, a block rests on the coefficient of static friction between the block and the plane. The sixth question, sorry, the coefficient of kinetic friction between the object and the plane is given by, oh, they've given that time taken is as much, n times as much. This is a 45-degree inclined plane, both of them are 45-degree. But for a rough surface, it takes n times more time. Suppose the time is t here, it's going to take nt to be the total time. Okay, so then that much time is going to take to slide down a perfectly smooth surface. It's going to slide down completely. Okay, so from the second one we can say that mg sin theta. So mg sin theta minus frictional force, and you know frictional force is mu into normal reaction. 1 second, hold on, somebody has come. So then let's resolve mg sin theta minus frictional force, which is mu into normal reaction, which is mu into mg cos theta, is equal to m into a. So that's how it's going to slide down, and that will give you the acceleration. So cancelling off the m, you can get the acceleration. So acceleration, you know sin 45, right? Theta is sin 45, which has been given. So a is equal to g sin 45, which is 1 by root 2 minus mu into g into 1 by root 2 is what is a. So thus you get the first equation in this. The second equation for the smooth surface, you know, mg sin theta will be equal to m into that a dash acceleration in this. And so then sin theta is sin 45, so it's m can be cancelled, and so then a dash itself is g into g by root 2. So you already know this is a dash and that is a, but you know that both of them are going to slide through the same distance when in inclined plane. S1 is equal to S2, so u is always 0 irrespective. So half into a for the left side one is g by root 2 half a t square time taken is equal to half into again a, which is for the second one a is and this is a for the second one, which is half a. Oh, did I consolidate a and find a? What have I written here? G by root 2 minus, okay, so then therefore half g by root 2 minus mu g by root 2 into, that's half a t square. T square is n square t square because it's going to take n times more time. So t square directly gets cancelled. Okay, and g can be taken out and can be cancelled with this. And root 2 can also be cancelled and 2 can also be cancelled. So you get 1 is equal to, and 2 root 2 also get cancelled. So you have a 1 minus mu into n square. So 1 by n square is equal to 1 minus mu. So if they ask you to find mu, it's 1 minus 1 by n square or n square minus 1 by n square. Let me see, because the options have not been given here. 1 minus 1 by n square, this is the answer. So you should understand that they both are traveling through the same distance, and so then you find their accelerations and equate both the s. Okay, it's such a beautiful question, simple ones, but unless you have learnt it, it's going to be difficult. A block rests on a rough inclined plane making an angle 3 degree, okay, with the horizontal. The coefficient of static friction between the block and the plane, mu static, is 0.8. If the frictional force on the block is 10 Newton, the frictional force itself is 10 Newton has been given. This is 10 Newton. The mass of the block is what you need to find. And we all know frictional force is equal to mu into normal reaction. A frictional force itself is given to be 10, which is equal to mu into a normal reaction. A normal reaction itself is so what is normal reaction? reaction, you know this is mg, and so directly this will be mg cos this theta, so mg cos 3 degree, right? Mg cos 3, and there will be above will be mg, so normal reaction will be this will be mg sin 3. So normal reaction itself is this, which is mg cos 3. So the you know g can be taken as 10, so in that case mu into m into cos 3. So can I write m to be 1 by mu cos 3, and what is mu? 0.8. 1 by 0.8 into cos 3. Do you know the value of cos 3? So how do I find this? Again, the question is a mistake. It's not 3 degree, it's 30 degree. Okay, it's given as 3 degree in the 7th sum. It's actually 30 degree. So that solves a problem. So then therefore you can write 30 degree here. And a cos 30 degree is nothing but 1 by 0.8. Cos 30 is root 3 by 2. So this is 0.4. So 1 by 0.4 into 1.732. And I will get the mass directly. And F is equal to, okay, now read the question. A block rests on the surface of the coefficient of static friction between the block is 0.8 if the frictional force is 10 Newton. The frictional force is 10 Newton. The mass of the block, so they haven't said that the block is sliding down or anything. Okay, so I have made a mistake. I have considered that frictional force, yeah, this is right. Frictional force always is mu into normal reaction. That is fine. Mu into normal reaction, where mu into mg cos theta. Mu is nothing but static friction. But my answer is wrong. I'll tell you why. Because they haven't said it's moving, so they are saying F is equal to mg sin theta. Okay, frictional force itself is not taken like this because it is not accelerating. F is equal to mg sin theta. So m is equal to f by g sin theta, and F itself is the frictional force, which is 10 Newton, by g is 10 into sin 30, and a sin 30 is nothing but 1 by 2. So then therefore mass is equal to 2 kg. So this is the way they are finding, and my thought is completely wrong. My thought, but we know that frictional force is mu into normal reaction also. Mg cos 30. Frictional force itself is 10 Newton. Mu has been given as 0.8. Okay, we have to think a little. So therefore children, let me tell you, whenever the block is at rest, you can't use this formula. Okay, whenever the block is at stationary, then you have to write F is equal to mg sin 30 only. That is the moral of the story. Just listen to this and make sure that we are going to follow this through in the class also. Okay, next question. The following questions I'll upload a separate video because my students have come. They need my help now, so I'll upload a little later.